Section 1.3 covers sampling and how to appropriately collect samples. Now, there are two types of studies in statistics. The first, which we'll be covering in this section, is called an observational study, where we're just watching participants. The second, which is covered in the next section, is an experimental study where we have some kind of treatment that's prescribed to subjects where we're trying to affect them. So as I just mentioned, in an observational study, we're just observing the subjects. We're not assigning them any treatments. We're not trying to influence how they behave. Okay, in an observational study, we're really just looking for trends or associations between two variables, and we're unable to determine if there's any causal conclusion to be drawn. When I say that we can't draw a causal conclusion, I'm going to tie it into a saying that you may or may not have heard. Correlation is not causation. And that means that when we have two things that are associated, it doesn't necessarily mean that one causes the other. Let's look at this example here. Suppose we have an observational study tracking sunscreen use and skin cancer and find that people who use sunscreen are more likely to get skin cancer than people who don't. Does this mean that sunscreen is the cause of skin cancer? Okay, obviously that's not the case. We know that the sun is more likely to be the cause of skin cancer, but there's what's called lurking variables in this. So maybe people who go out in the sun are more likely to get sunburn and use sunscreen. Okay, also maybe people with lighter skin are more likely to use sunscreen and get sunburn. Okay, so unless we randomly assigned these subjects to use sunscreen and not use sunscreen, we can't draw any causal conclusions about what the actual cause is. Now, there are three types of observational studies that are differentiated from when the data is collected. So the first is called the cross-sectional study. This is where we collect data from a single point in time. The next is called a retrospective study. When you think retro, you think old. This is where we collect data from the past. We go back, we look at old records or something like that. And the last is a prospective study where we collect data into the future. Often we'll be tracking participants along with habits or something like that into the future. Some examples, let's classify each of these studies into what type it is. These are all observational, so we're just classifying based on the three cross-sectional, retrospective, or prospective studies. So first, a researcher plans to track the health of 10,000 teens to see if there's an association between illnesses and vaping. Since he plans to track that data, this is going into the future, which makes it a prospective study. A statistics teacher examines last year's AP report to identify areas of weaknesses among his students. Last year, this is past data. This is a retrospective study. Okay, you can probably already guess. Data is collected at Friday night's football game to determine if blue or red Gatorade sells better at the snack stand. This is collecting data from a single point in time, just on Friday night. This one is cross-sectional. In most cases, we collect data for an observational study by conducting a sample. And there's a number of different ways we can conduct a sample. Here are the main ones. So the first is a simple random sample. This is when we're collecting a sample of n subjects, and they're selected in such a way that we can end up with any group of the same size. They all have the same chance of being chosen. Emphasis in simple random sample is on simple. Think about just putting everybody's name in the hat and drawing 10 names out of the hat. We could end up with 10 girls. We can end up with 10 boys. Maybe we'll select the 10 youngest or the 10 oldest. All right, there's no restrictions on who we can pick. It could be any group of 10, and they're all equally likely to be chosen. A systematic sample is when we start on a certain number and select every kth person, where k is some number such as the 6th or the 10th. So we would start on the 6th person, and then we would select every 10th person after that, for example. A convenience sample is a sample that's just easy to obtain. A stratified sample begins by breaking the population into two or more groups, and then we perform a simple random sample on each group. Let's say we want to conduct a sample on high school students. We could start by separating them by gender, and then perform a simple random sample on the males and the females. Or maybe we'd separate them by grade level. Freshmen, sophomores, juniors, seniors, we take a sample of each of those grade levels. This makes sure that each grade level is represented in our sample. Cluster sample is really similar in the sense that This also starts by breaking them into groups, but the groups are a little different. So sticking with that high school students example, clusters, we have groups that are largely representative. Let's say that they're gym classes. And to keep it simpler for ourselves, we're just going to pick one of those groups and perform a census. So maybe we pick one of the gym periods. Let's say we go into second period and then we survey all of the people in that gym period. It should have males and females. It should have freshmen, juniors, freshmen, sophomores, juniors, seniors, etc. Here's a visual representation of stratified versus cluster sampling. Let's say we're polling for an election. We have a state here that has 32 districts. We want a sample of a couple thousand people. If it was stratified sampling, we would take each district, perform a simple random sample of each, and say take a sample of 100 people randomly from each district. In cluster sampling, we randomly select a handful of districts. In this case, we're going to take 3, and then we perform a census on those 3 districts. If those districts are representative, if they match the whole state, it's easier than going to every single district. The problem is that maybe we pick 3 districts that all have the main cities, so it's too urban, or maybe we don't get any cities when we randomly select. Maybe we get a whole bunch of retirement communities or no retirement communities, etc. To round it out, we have a voluntary response sample. This is when subjects choose whether or not to respond to a survey. These samples are almost always biased because people who are able to opt into a survey are likely to have strong opinions either for or against what they're being asked about. And lastly, multi-stage sampling is just when we start to combine the different methods that we just went over. So in this example, we have a lecture hall. There's 200 students sitting in 10 rows. Each row consists of 20 students. The professor wants to estimate the amount of financial assistance received per student. Name the sample if the professor, number 1, generates a random number between 1 and 10, selects the row corresponding to that number, and samples all students in that row. So he's picking a row, that's the group. He's performing a census on that group where he's talking to everybody and asking everyone in that row that question. That makes this a cluster sample. Number 2, puts all students' names into a hat and randomly selects 20 of them. Okay, in this case, he could end up with any group of 20 students. Maybe it's the 20 in the row we just picked. Maybe it's the 20 who sit in the front or the back, or 20 females or 20 males. It could be any 20 students. This is a simple random sample. Number 3, randomly selects a number between 1 and 10, and starting with that student, samples every 10th student. This is a systematic sample. Number 4, samples the first students that come to class. Notice that this sample doesn't have any kind of randomization. That's always a bad sample. This is a convenient sample because the professor's taking the easy way out. He's just asking the students that are easiest for him to ask. Number 5, assuming that the more engaged students sit in the front and the less engaged students sit in the back, he randomly selects 2 students from each of the 10 rows. Again, we're breaking the population into groups, but unlike cluster sampling, where we picked a group and we performed a census and picked all of the students in that row, we're taking 2 from each of the 10 rows. That makes this a stratified sample. And lastly, asks 20 students to come retrieve the sample and samples only those students. This is a voluntary response sample. These students are opting into the survey. They're not going to be representative of all of the students.